Welcome everyone, which may be the last official video here before we close out the year in this further math course. What I'm going to attempt to do is something that probably shouldn't be attempted, and that is to give an overview of really weeks and weeks worth of work if we were in a traditional class setting. Keep in mind that with this statistics unit as well as the calculus unit, we assumed you had a pretty good base of knowledge, and through just a little bit of practice in certain types of problems, you hopefully be able to attempt those problems and complete certain problems. So here we go. I mentioned last time that this central limit theorem was kind of the border between the early part of the unit, which is a lot of the mathematics behind our statistics and probability, and then we move into kind of a different task. Just a final reminder on the central limit theorem, it's rather important, especially in terms of maybe social sciences. There might not be any statistics in the social science course if we didn't have this theorem. Because again, sometimes we just don't have hard data. We can't really prove things, what you might consider mathematically. But statistically, we can find out some things. Here are a couple ideas that we have this probability being x over n. If n is sufficiently large, whatever that may mean, and that could be different in different situations, we can let that p be about a normal distribution, or approximately a normal distribution. And these would be the parameters of the normal distribution, the actual parameter probability, and then of course this would be the adjustment. Before I get into some of these details, I think it's important to understand the big picture here, what we're trying to do. And it's so important then to study the types of questions that are being asked. We typically want to take a sample. We then want to ask ourselves some questions about that sample. Is it a good estimate of the whole population or not? We can find some estimates. We can make some inferences. Once we do that, we can then maybe ask ourselves some confidence. You know, if we do have some data, then after that, how confident are we that it would fall within a certain probability? We could get more confident as the interval gets larger, and if it gets smaller, we can sometimes be less confident. And what's appropriate for that? Based on some of this, we can come up with a hypothesis, come up with a statement that we believe maybe can be true. And then we can, of course, test that hypothesis. Now, many times when we test something, we have certain types of errors. So once we test it, we find out whether it's good or not. If it's not, there can be certain types of errors. So that's kind of really the flow of all of this big picture stuff. As I said, study the types of questions. A lot of this is going to be very important here over the next several months as we get into elections and other types of things like that. Because, you know, when you see all of this in the media about what's happening in terms of polls and data, it's nice to know some of the mathematics behind it. Sometimes the more you know about it, the more complicated it gets. So that's why sometimes people oversimplify, but that's another story. So here we go. In section F, we do talk more specifically about the estimators and inference. There are simple calculations on the unbiased estimates of mu and sigma, or the biased estimates, and how would you know if it's biased or unbiased. So you could have a question to find an unbiased estimator. We then move into confidence intervals. As I said, confidence intervals, if you think of area under a curve, it's kind of how confident are you that your data fits within a certain section. And if we assume or approximate it as a normal, we can use some of those same things that we knew about the normal. Mainly, one standard deviation on either end, we get about 90, really maybe a little bit different, but we'll call 95%. There's a nice table on page 92 that talks about some of these confidence intervals as it spans out from the mean. Many times we do not know either mu or variance, but there are still ways, of course, to be able to approximate that based on the estimators. If we then go back and figure out the population mean or variance, then we can go back and do some recalculations. T-distributions or student T-distributions play a part, and that's, I guess, comparable to kind of standardize things. And then we have this little phrase, I'll let you work on, degrees of freedom when dealing with these distributions. Well, we then move into the hypothesis. Hypothesis is just a statement about the value of a parameter. Keep in mind, all of this is either based on a parameter or a statistic. Parameter, of course, being, well, you know that. As far as the statement about the value of the parameter, we could have a hypothesis called the null hypothesis. We could have the alternate hypothesis. So we might state that we think something is true. All right? And then, of course, we could make an error. We could also have an alternate hypothesis. If we have a type 1 error, we say, well, I'm going to reject that, and I'm going to provide some data to try to reject it, but it turns out to be true. Or I could accept it, and I provide data and find data, but it turns out to be false. Now, of course, you could have the null hypothesis that fits within our confidence interval, and we could accept the hypothesis. There's nothing wrong with accepting hypothesis. This is only if we reject it. P-values are basically probabilities. P-values can help us make a decision there. P-values are really where it's going to, again, lie if we think about that area under a curve. And then if figuring out error isn't enough, we can find the probability of error. Because every time we make approximations, there is some error, but what's the probability that we made that error, and how much of an error? So we have the one-tailed and two-tailed error. And then we wrap things up with bivariate statistics just a little bit, because this is a very normal thing to work with. Bivariate statistics, basically we have two of the same, and what I mean by that is we maybe have two characteristics or particulars or things that you're testing in the same situation. A nice example in the text, I think, might have involved the height and shoe size of a person. You would kind of assume they're somewhat connected, but how connected are they? And can you make some predictions based on knowing someone's height is what their shoe size would be, or vice versa? So when we deal with bivariate statistics, there's this R value that comes into play. And we also have this thing called covariance. How connected are they? And the covariance can be defined a couple different ways. Well, not really. This is more of the formula version of it. It's the expected value of the product minus the product of the expected values of each individual. And then we still have this P. We still have that probability. And it's calculated by the covariance over the square root of variance of one times variance of the other. So T, Z, P, and R, these are different letters that we'll tend to work with in terms of these probabilities and statistics. But again, I can't stress enough that what we're trying to do here is to very quickly give you an overview of some of the language of statistics and probability and some of the big types of questions that this can address. A lot of the details are kind of on your own to look through the text and study some examples if you find a problem that you need some of those. Because the mathematics behind it is rather interesting, and again, it would be fun to spend time in class and develop some of these ideas. But for now, I think this would suffice, so at least you know the types of questions that we can attack and answer using this topic. That's pretty much it. What we'll be doing next is on Friday, I will post paper 1 of an actual IB test. And then a couple days later, probably next Tuesday, I will post paper 2. They're 2.5-hour papers. I'll put in an email as far as how I'm going to hopefully allow you to attack those and get some feedback on them. But hopefully, again, that will just give us some nice closure to the year, so we can, look back and say, you know what, I've learned a lot about many different parts of mathematics, and I can do these types of problems, and then you can be ready to move on. So that's the end of the stats unit. If you have any questions or concerns, again, please continue to let me know. I will also post some sample problems on F through I topics very soon. Thank you.